Try to open it using some other thing. Anyway, we discussed the instruction set, right? All 248 instructions we tried to cover. But before moving to 8086, right, we have some time, right? Like by the time in section B, right, module 2 is completed, like interrupt and its related programming. By that time, we can revise the instruction set once again, so that anyway, here we can see that it is 8085 instructions we can divide in 5 groups. No, first is data transfer group. So you can see move command, move a comma a comma b, a comma c, a comma d, a comma e, all are there, right? Last instruction is important one, move a comma m. Hello?
Yes, sir.
What is the difference between a comma move a comma h and a comma l? What is the difference between these two? Move a comma h. Yes, anyone can explain me?
Sir, in a comma x, the values of accumulator. Okay, sir.
Yes. Hello?
Yes, sir.
What is the difference between the two, a comma h and a comma m?
Sir, if you do move a comma h, so the value which is in h register will get stored in the accumulator. But when we do a comma m, then the pointer location stored in h comma l will be uploaded onto the accumulator.
Once again, can you repeat this?
Sir, if we do a comma h, sir, then what will happen means the value of h will go to a register.
But means, when we do value of h will be copied to a register. So
yes, sir.
Right. Next, a comma m, what will happen?
Sir, the value present in the memory, memory number which is there in h comma l will be stored in accumulator.
What is h comma l?
Sir, h comma l is registers, no sir, 2 registers. So it
will HL. You should not say h comma l. It has to be HL pair.
Yes, sir, HL pair.
Right. So HL pair will have a 16-bit data, no? Here you will have 8-bit, here you will have 8-bit. So a 16-bit data will be there in HL pair. So move a comma l is going to do what? Hello? Suppose inside HL we have 2475. Now move a comma m is going to do what?
Sir, it will store the content which is present in 2475 RAM location.
Where it will store?
It will be in the RAM, sir. It might be getting stored into temporary register. It is in the RAM.
What? Move a comma h, content of h will be copied to accumulator, right? Move a comma m, content of memory location pointed by HL pair like 2475. So whatever is the content of this location will be stored where?
Sir, in the
In
accumulator.
some temporary register.
Yes, sir.
Why? Why not in accumulator? So this one is now if I am writing say move a comma m, right? You are saying content of memory location will be stored in some temporary register, not in accumulator.
No, sir.
Right.
It will get stored in accumulator only, sir.
Huh?
It will get stored in accumulator only, sir.
Accumulator only.
Yes, sir.
But you said earlier no, that it will be stored in temporary register.
No, sir. I was referring to the in HL pair, sir. There is a memory address, sir. In that address, what the thing is there stored, that will get into accumulator, sir.
Anyway, another thing, see, suppose move a comma h is executed, right? So what will happen? Finally, a will be equal to h. Suppose h is equal to 4, 5, right? A is equal to some xx value is there. Finally, a equal to h equal to 45 will be there. But initially, this 45 will be copied to temporary register. And from there, it will go to accumulator. This I discussed earlier. Right? In order to reduce the micro instructions. Because you can see here, 8:8, around 64 different operations are there. Data transfer operation, no? A comma A. Right? You can see around 64 or 63, no? You can see the 64, but move m comma m is not there. So around 63 different micro instructions you need in order to perform these type of operation. But if you use the temporary register in between, suppose move a comma b, right, will do what? First of all, it will move temporary to b, then move temporary to a. This way it will do. Right, so it will reduce your micro instruction only up to 16. Next instruction, MVI byte. MVI A, MVI B. So suppose if I am writing MVI D 45H, what exactly it is going to do? Quickly. Hello.
Sir, in D, 45 will be stored. In D, 45 will be stored, sir.
D will be equal to 45H, no?
Yes, sir.
If I write MVIM 77H, what exactly it is going to do? Quickly. बंद करो ठीक से भाई.
Sir, in
Yes.
address pointed by HL pair register, 77 will be stored.
Yes. Yes. Right. Now, these move instructions are of 1 byte. Right. So, processor needs to out the program counter only once for fetching these instructions, move instruction. But this MVI is of 2 byte, no? One is opcode, then followed by a byte, right? MVI D16, then 45. So it is a 2 byte instruction. So how many times program counter will be outed in order to fetch the complete instruction? How many times program counter will be outed?
Sir, 2 times.
2 times. Good. Next, another data transfer instruction you can see LXI B. LXI B is there. LXI D is there. LXI H is there. LXI SP is there. If I am writing, say LXI H 3789H, what exactly it is going to do? It is a 3 byte instruction, right? It will do H will be equal to 37 and L will be equal to 89H. Load extended register pair. Extended register of H is what? L. So this one is the register pair, will be loaded with what? 3789. Right. So when we write the opcode for this LXI as 3789, how we are going to do that? LXI H is 21, no? 21, then followed by 89, then it will be 37. Okay. Hello.
Yes, sir.
Right, because lower byte, that is 89, has to go to L register. So this has to be stored in lower location. Higher byte, which will go to H register, which has to be stored in higher location, no? And this one is the opcode. And it is a 3 byte instruction. In order to fetch the complete instruction, right, processor needs to out program counter 3 times. Okay. Okay, next instruction is LDAXB and okay, similarly we have LXI B, H, SP. SP stands for stack pointer. Right. So stack pointer has got 2 registers, SPH and SP low. SPH and SP low. I should write here like this. Okay. SPH and SP low. 2 8-bit registers are there, are combined to used as stack pointer. Right, like HL, BC, DE, HL. Similarly, we have this. Similarly, PCH and PCL is also there. 16-bit program counter is also having PCH and PCL. Anyway, so next instruction we have LDXB. Right. So what exactly this instruction is going to do? Hello?
Sir, it will store the value. If BC is there, sir, in BC register pair, we have a memory location. So
That
the memory location
you tell me first. Hello?
Yes, sir.
BC register pair, you tell me the memory location so that I will write over here.
Sir, I need 2401.
2401 H. Right. So this is 2401 H. So what will happen? Hello?
Sir, the values stored in 2401 in the RAM will be loaded into accumulator.
Okay, in the RAM, not from ROM. Hello?
Sir,
Suppose it is 2401 is the ROM location. Will it read or not?
Yes, sir. It will read.
Okay. Okay.
It
Okay.
will read.
It will read. Similarly, LDXD, right? D is pointing to some memory location. From there, content will be loaded to accumulator. No? Is it okay?
Yes, sir.
Now, stacks B, accumulator content will be stored in memory location pointed by. Hello?
BC register, sir.
BC register there. Right.
But only
Similarly,
RAM, sir.
stacks B is also there. Right. Now, how to store accumulator content in memory location pointed by HL pair? How to store that? Which instruction we will use? Hello? Hello? Use.
Sir, move M comma A, sir.
So, stacks H is nothing but. Hello? Hello? बाद में move M comma A, no? Stacks H is not there. This instruction is not there, no? So move M comma A is there. It is also 1 byte instruction. Similarly for LDAX H, what we have? Move A comma M. ये नहीं है. All are 1 byte instruction. Okay? Hello? Respond.
And what is the question, sir?
Uh-huh.
That's
No,
the question.
I was just saying that we don't have here, no? Here only BC and D register pair are there. Here you can see it is BC and D. Here also BC and D. What about HL? So for HL it is move A comma M.
Yes, sir.
है कि नहीं? And it will be move M comma A. Right, we don't have stacks H or LDAX H like this, no?
Yes, sir.
But you can see advantage of having this move A comma M and M comma A. You can transfer to any register from memory location pointed by HL pair. You can transfer content of memory location to any register like A, B, C, D, E, H, and even L. Similarly, content of accumulator or content of any register A, B, C, D, E, H, and L, you can store to memory location pointed by HL pair. But here, content of memory location pointed by BC or DE pair is copied only to accumulator. Hello?
Yes, sir.
Is the difference is clear?
Yes, sir.
Okay. Now LDA, of course, this is a 3 byte instruction. If I write say LDA 2700H. Oh, okay, 2745H. So what exactly it is going to do? It will load the content of this memory location 2745H to the accumulator. This is a 3 byte instruction. So how many times program counter will be outed in order to fetch
times.
Huh?
3 times.
3 times. How many times read var will be made low in order to execute this instruction?
Sir, 2 times.
Sorry.
Sir, 2 times.
Sir,
Anyone? Someone is saying 2 times, it is wrong.
sir,
3
three
times.
times.
3 times
Yes, sir.
program counter will be outed in order to fetch the instruction. So how you are saying read bar will be made only 2 times? Read bar will be made low only 2 times. How you are saying that? So minimum 3 times will be there in order to fetch the instruction completely. But for execution, another 1 time you have to make the read bar low. When reading the data from 2745X, so it will be 4 times. Read bar will be made low by the processor. So those many times ALE will be also made high. Right?
Yes.
So right. Similarly, for STA, say 2839H, what will happen? Accumulator content will go to memory location 2839H पे क्या है? यहाँ पे हमारा XX आ जाएगा जी. A is having XX. Then at 2839H, this will go. This is also 3-byte instruction. And this is for storing the accumulator content onto the memory location 2839H, no? So how many times read bar will be made low in this case? Hello?
Sir, 3 times.
3 times. How many times ALE will be made high?
Sir, 4 times.
4 times. How many times write bar will be made active? How many times write bar pin or signal will be made active by the processor? Hello? Of course, after reading the instruction completely, right, program counter will be outed 3 times because it is 3-byte instruction. So ALE will be 3 times, right? Read bar will be 3 times, and 4th time 2839 will be outed. And that time again ALE will be made high, so it will become 4 times, and write bar will be made active so that content of accumulator will be written onto the memory location 2839H. So 3 times read bar, 1 time write bar. Okay. Next instruction you can see LHLD address. LHLD address. So 3578H. What exactly this is going to do? This is a 3-byte instruction. It is used for loading HL pair. Right? It is used for loading the HL pair from the content of memory location 3578 and 3579H. Right? So suppose at 3578 we have this XX, right? And at 3579H we have YY. So if this instruction is executed completely, what will happen? Tell me quickly.
Sir, the content of 3578 will go into the L register and the content of 3579 will go to H
tell
register.
L equal to XXH. Right? And H will be YYH. Okay? Hello, this is
Yes.
what. Similarly, SHLD, store HL pair to this memory location, say 3, 4, 5, 6H. So right now, L is what? XXH. So add 3, 4, 5, 6, you will have XXX, right? And at 3, 4, 5, 7H, क्या होगा? YY. Okay. Hello.
Yes, sir.
I should decrease the thickness. Now next data transfer, you can see XCXG. Only one instruction is there. XCXG. This is used for exchanging the content of HL and D pair only. Right. Here, that data is already defined by 2 register pairs. Right. So suppose if I am writing LXIH 2575, LXID 3898. If you do XCHG, what will be HL pair? Hello? HL will be 3898. Right? And DE will be 2575. Hello?
Yes, sir.
Yes, sir.
So this is used for exchanging the content of HL and D pair only. We don't have any other instruction related to exchanging the content of BC and D or BC or HL. We don't have. Right? It is only one instruction and is used for exchanging the content of HL and D pair. Right. Then we have arithmetic instruction. Add A. What exactly it is going to do? Tell me quickly. A will be A plus A. So how it will be done? I need to just 8085 architecture. Delete. Copy image. Paste. Now, if I say go to this, what is the opcode of move A comma A? It is 87. Right. So if 87 is inside this, ये क्या हो गया जी? Right. If 87 is inside this, opcode of instruction is over here, what will happen? Processor will understand that it has to perform A plus A. So how it will be done? So accumulator content will be copied over here. Then here A plus A will be done. then this result will be stored back in the accumulator. How it will be done? First of all, A plus A will be done, then it will be stored in temporary. Then from temporary, it will go over here. Right. In fact, this should be bidirectional. Okay. Hello.
Yes, sir.
Yes, sir.
So now I am saying this. I am going for next instruction. No
Sir,
need to
excuse me,
explain
sir.
all this. Hello.
Sir, could you continue in next class, or we have a class now?
Okay. Last instruction I am going to discuss only. Right. I am going to discuss only this. ADC add M. This is a very important one. So if suppose 86 is over here, instead of 87, suppose here we have 86. A86. 86 means add M. What it will do? Hello?
Sir, it will add the value which is pointed by the location stored at HL pair.
Okay, okay.
Yes.
So 86 comes over here. Processor is going to understand what exactly it is going to understand. Whatever is the content of HL pair, from that memory location, data has to be copied to temporary register. Is it okay? So suppose it is 2489 is there. So 2489 is outside, no? Memory location. Here we have XX. So if 86 is there, processor is going to understand. It has to out 24 from here. And it has to out 89 from here. So that address of the data is outed and it comes over here. Processor will make read var low so that this XX will come into this via AD0, AD7 and it will go into over here. Then A plus XX will be done and result will be stored back over here. A plus XX will be stored over here. Okay. Hello.
Yes, sir.
Anyway, we have this week we will continue with this revision only. Right. We have so many free periods now we are having, like DCOM, digital communication. That time also you are free, huh? Hello.
Yes, sir.
So much time is there for us, right? We can utilize DCOM lecture timings in order to discuss these things, right? For discussing all these things in detail, right? So moment say module 2 finishes in section B, right? Not module 2. In fact, module 1 finishes. Sorry. According to your syllabus, right? If module 1 finishes, then module 2 8086 will start. Okay. So I am